Hi folks, welcome to another episode of Impossible Feats. I'm your host Robert. On last week's episode, we saw our contestants juggle flaming chainsaws while walking a tightrope over a pit of hungry alligators. I'm pleased to report that 3 out of 5 contestants survived, and 1 may even walk again. Way to go, you crazy daredevils. But this week we're ratcheting up the insanity to a whole nother level. That's right, we're asking our contestants to do something truly impossible: to build robust, performant, data-driven apps. Our contestants are going to be asked to fetch just the needed data, no more and no less, while avoiding network waterfalls. Our contestants are going to be asked to split network requests in order to show high-priority content to the user as soon as possible, while avoiding fetching the same field twice. They're going to be asked to load just the JavaScript that they end up using. They're going to be asked to ensure that their apps are responsive and reflect the latest data while avoiding unnecessary re-renders. And they're going to be asked to garbage collect unused resources so that their apps don't on low-end Android devices. And boy, do I got some stinkers for them. But as if that wasn't challenging enough, this week we have a secret challenge. That secret challenge is other people. That's right. Apps are living, evolving things, and our contestants are going to be asked to maintain that performance profile even as other developers make changes willy-nilly. Okay, if our contestants are going to survive, they need strategy. Let's talk strategy. In order to avoid network waterfalls, our contestants are going to have to make network requests for all of the data needed by a given page in a single go. That provides a pretty good user experience. There's one loading state, all the content pops in. It also provides a pretty good developer experience when initially writing that page. However, the real problem comes when our contestants come back from a week-long bender in Tijuana. Where is the thing? There we go, week-long bender in Tijuana, only to find that the dastardly other developers have made changes and they don't remember how the project works anymore. At this point in time, our judges will ask our victims, contestants, to stop using a field in subcomponent. They'll stop using it, they'll go to the query declaration and ask, can I remove it from that query declaration? The answer is, I don't know, not without doing a whole bunch of research, not without tracking where that data goes and seeing if any other subcomponent is using that field. And what about through something like json.stringify or object.keys? Or what if one of those other dastardly developers lands a change at the same time that starts to use that field? This problem is further compounded if that component is used across multiple screens. Now, we engineers, we consider ourselves rational. We respond to incentives. We think, if I remove that field from that query, I can make the app slightly faster, but on the other hand, I risk breaking production. So we know how that plays out. It doesn't get done. Queries become bloated, filled with fields that are probably unused, but which nobody is brave enough or stupid enough to remove. Okay, I hear what you're saying. This is GraphQL Conf. We have a solution for that. And that's exactly right. GraphQL is amazing. GraphQL allows each component to define the data it needs in a fragment, and that at compile time, a single network request or a single query is generated for all the data needed by a given screen. But that's a killer feature of GraphQL. And if we ever move away from that fragment composition model, something has gone horribly wrong. I'm here to tell you that that's great, but it's not enough. Luckily, our contestants will have limited time simulating the arbitrary deadlines they have at work. And as such, they can't be spending time setting up some framework or futzing with boilerplate. If the framework doesn't get out of their way and let them build, it could be their last. Luckily, our contestants have access to a secret weapon. That secret weapon is Isograph. Isograph is a framework for building React apps that are powered by GraphQL data. It has ambitions to be a framework for building apps powered by data, but all in due time. It has 4 goals: to make app development as frictionless as possible, to make it easy to build to give developers the confidence that they won't break production, to make it extremely easy to build performant apps, and to expose powerful primitives to let developers precisely model their domain. It's very much a work in progress, but while doing research for this episode, I came across this roadmap from a year ago, and so many things that were theoretical then are real now. 7 other developers have contributed to Isograph, and it's in use in real projects. Okay, let's talk about how our contestants are going to use Isograph. In Isograph, a developer defines a component along with the data it ends up using. So consider this blog post header defined with that ISO function. It selects the title and author, which are GraphQL server fields. These then get passed in as part of that first parameter to this function. We're defining a component, so what do we do in that function? We return some JSX. Now, throughout this episode, you're going to be hearing the term client field a lot. A client field is a function from some graph data to an arbitrary value defined with that ISO function. This blog post header, that's a client field. The important thing to note about client fields is that they can depend on each other. So if we take a step back, we can take a look at this blog post display. This is another client field. It selects the blog post header and blog post body. Those get passed in as part of that first parameter. And what do we do in that function? Well, those are components, right? So let's just render them. That is the developer experience that Isograph provides, and it is honest to goodness, real functioning Isograph code. Okay, let's talk about what we didn't do. The blog post header didn't care how the title and author were originally fetched. It just received them. When we wrote the blog post display, we didn't explicitly import the blog post body. We just received it from Isograph. And furthermore, the blog post display didn't pass any data down to the blog post header. In fact, the outer component didn't see or have access to the fields that the child component ended up using. This is great because it means if those other dastardly developers make changes to the blog post header, well, nothing will break because the behavior of no other client field will change. Another thing we didn't do is explicitly type anything, and yet that first parameter is fully statically typed. Now, we're writing components here. Components take props. How do we do that? Well, these client fields can take props by being given a second parameter. Here we add this onClick prop object, and as a result, as soon as we do that, everywhere we render the blog post header is going to have a type error. Where is this magic coming from? Throughout this, our contestants are going to be running the Isograph compiler in a terminal. The Isograph compiler on every save scans your code base for these Isograph literals and generates a bunch of files. If you make a mistake, as you are wont to do because you are mortal, the Isograph compiler will helpfully print out an error message telling you exactly what you did wrong. If the Isograph compiler encounters an entry point, which is analogous to the root of a GraphQL query, one of the generated files will contain the query text that is sent to the backend. This query text will contain exactly the server fields that are used by any client field accessible from that entry point. So this means that if we modify a client field to stop selecting a given field, it will be removed from the query if and only if no other client field in that entry point is using that field. This is great. It means that we can make changes to client fields with impunity and be assured that the network request we send to the backend contains exactly the needed fields, no more and no less. Now, we're building a data-driven app, so let's go ahead and use that entry point to make a network request. First thing we'll do is we'll pass it to useLazyReference, which is a hook that, when initially rendered, makes a network request for the data needed by that entry point. It gives us back a fragment reference whose result, and we can read the results of the network request by passing that fragment reference to useResult. Now, useResult will suspend while that network request is in flight, and when that network request completes, tell React to re-render that component. When we re-render that component, we get the blog list and we render the blog list. The blog list renders the blog post display, which renders the blog post header, and so on and so forth. And thus, the entire app is rendered. If you understand that, you understand the gist of how Isograph works. But I can see it in your faces. That's not good enough. It's 2024. Apps do a lot more than just fetch data. They load data when the user clicks on something. They paginate. They pull for updates. And not to mention, loading all the data in one go isn't always great for performance. And what happened to just loading the JavaScript that we end up using? Well, I'm 10 minutes into this episode and there's still so much carnage that I need to show you. So if you want the full answer, you're going to have to buy the DVD edition of Impossible Feats. But wait, what if I told you that all these interactions, yes, every one is powered by the same fundamental building block? What do you say, audience? Do we have time to teach our contestants about one more superpower? All right, let's teach them about one more superpower. That superpower is loadable fields. A loadable field is like an entry point that's embedded in another query, and it's a fundamental Isograph concept. Let's take a look at that blog post display again. We really care that the blog post header is rendered as soon as possible, but the blog post body, it's got some slow to calculate fields, and so we would like to, load it a little bit later. One way we can do that is by annotating the selection with this @loadable. Now, the parent query will not include the data for the blog post body, and instead of receiving the component directly, what we're going to receive is a function that, when called, makes a network request for the data needed by the blog post body. We can pass this so-called loadable field to use client-side defer, which is a hook that, when initially rendered, makes that network request, which gives us back a fragment reference. And like last time, we can pass that to use result to read the results of that network request. However, that will cause this component to suspend, meaning that we can't render the header as soon as we otherwise would, sort of defeating the purpose. So instead, this time around, we're going to pass it to fragment reader, which is a wrapper around use result, and wrap that in a suspense fallback. So now, when this component initially renders, we kick off a network request, we show a suspense fallback, and when that network request completes, we render the blog post body. And if this sounds like defer, that's exactly right. This is defer, but with strictly worse performance, because we're kicking off the network request during render. But the point is this: Isograph has your back. If you don't have a server with the latest and greatest bells and whistles, you should still be able to use this more performant pattern where it matters. And when you finally are able to upgrade your server, Isograph will provide you a smooth upgrade path to the better performing pattern. Okay. If we're asynchronously loading the data for the blog post body, isn't it also a best practice to also asynchronously load the JavaScript? Now, in every other framework, with one exception, there's no connection known at compile time between the data that a component uses and the JavaScript. So it's always going to be two separate steps to asynchronously load that component. But on the other hand, Isograph makes that easy. With just one minor tweak, now when this component initially renders, we'll make a request for the JavaScript for that blog post and for the data. And if this reminds you of relay entry points, that's exactly right. This is relay entry points requiring no server support and doable now in userland with loadable fields. Okay, what else can we do with loadable fields? Well, what if we call it in a set interval? Hey, that's like a live query doable now in userland with loadable fields. Or what if we call a loadable field a bunch of times and pass different parameters and concatenate the results? Hey, that's pagination implemented in userland and doable now. Isograph ships with a use skip limit hook. But what if that's not right for you? What if you want relay style pagination, or you want to add reverse pagination, or you're one of the crazy types that wants to add Reddit style threading? Well, this is all implemented in userland, so you can make whatever changes you need. I mean, it's not trivial. There's some bookkeeping involved so that there's no memory leaks, but you can do it. And furthermore, there's no magic involved in integrating with a router. And if you want to keep a hash map of loadable fields, by all means, go for it. You can model your state using whatever algebraic data type is appropriate for your situation. Okay, let's go back to loading only the JavaScript that we actually need. Let's consider a newsfeed. Imagine we have a newsfeed with not just text posts, image posts, and videos, but events, songs, albums, fundraisers, and more. And not to mention 50 different variations that you'll only see if you're part of some A/B test. Well, it's incredibly wasteful to send all of that data down to all that JavaScript to every user because they won't see every variation. And it's a huge disincentive to experiment if adding a new variation bloats the bundle for all your other users. Well, loading only the JavaScript for the types of objects that we actually encounter, that's Relay 3D, and it's the superpower that allowed Facebook to make their newsfeed load so quickly. And you guessed it, it's doable now in userland with loadable fields. Now, I don't want to pretend it's all sunshine and rainbows. There are severe limitations to when and where loadable fields can be used. But the point is this, they don't require server support. None of this was possible a year ago, and the roadmap contains everything that it's going to take to get to comparable performance. Okay, with that caveat aside, let's prove that Isograph is not vaporware and take a look at a real, honest-to-goodness Isograph app. The, how do I do this? Okay, don't mirror. How do I stop mirroring? A real Isograph app. The lorem ipsum blog. Okay, let's try extended display. Wait, now that reversed it. That's not good. Okay. I'm 90% certain this is exactly what happened last year when I tried to. Okay, mirror? Yeah, mirror's good. That's what I wanted. Okay. So here is the lorem ipsum blog. First thing you'll notice is that as we scroll, we're going to make a GraphQL request for additional data. Oh, it's failing. Okay. Let's load it in a new tab because I don't really know what's going on with that. And I don't want to risk it. Why is it failing? Okay. Well, I don't know. Let's try restarting the server real quick. Not sure why this is happening. But, and in the meantime, we can take a look at how this is actually implemented. So if we start with the newsfeed pagination, we actually have this newsfeed adder blog here. And this is how we do 3D in userland right now. We have a bunch of fields that are nullable, and so we're just assuming that there's actually only one of them present at any given time. Isograph will at some point in time support unions and so on, but that's not the case right now. So if we jump to add item display, what you'll see is we have exactly what you expect. There's a loadable field with use lazy load, with use client side defer and lazy load artifact true. And this is passed to fragment reader, which then unwraps it and reads the result. So if we go here and do add item display instead of the wrapper, now without doing any changes, without doing any substantial changes, now if we paginate, we'll find that we're not loading the JavaScript separately. Okay, let's give that thing another try and see what the hell is going on. All right. Okay. All right. Network. I don't know. All right. You know what? That's what happens when you try to do live coding. All right. Going back to the. Your network is set to offline. Am I? Oh, yeah. Oh my God. Oh my God. You're a genius. You're a genius. See, I don't know how to program. I promise you. Okay, so let's get back to this. Okay, so now if we scroll down, we see that we get a GraphQL. Here we go. Woo, okay. Woo. Okay. Now, everything is sponsored nowadays, so if we scroll down, we're going to encounter another ad. Oh, actually, we're not going to encounter an ad because I made that change locally, so let's just go ahead and undo this change and go back to what we were originally going to demo. It doesn't like hot module reloading. Okay, so now we scroll down. We see that we're paginating. The next time we paginate, we're going to encounter an ad. Like we saw with the add item display wrapper, that ad, the JavaScript is not included in the parent bundle. So the next time we paginate, we see the JavaScript for that ad. That's kind of awesome. So now if we click on load more content, well, we're doing the same thing. We're loading a loadable field and then getting the GraphQL. And if we click on load more content an additional time, well, we're not loading the JavaScript again because we keep track of that. Okay, and if we keep on scrolling, we're eventually going to encounter some blogs that have images. Hey, there's the image. And one thing you'll notice is that before we hit that, when we encountered a blog with an image, we fetched the JavaScript for that image renderer. Okay, well, that's what I was going to show you. All right, that was a bit of a heart attack earlier. This happened during a dry run. I wasn't really sure why. Okay, so it's 2024, and every presenter is contractually obligated to have a section on what this means for AI. So, I mean, we've all heard of LLMs. They're this like experimental technology that's, maybe a few years out before being useful. And yeah, at some point in time, people will start making tentative steps into using LLMs for things like making recipes or eventually building data-driven UIs. Now, I mean, people do what people do, so we should take advantage of the fact that we have several years of heads up to think about what framework is going to be the best for building data-driven UIs with the help of an LLM. I'm going to make the case that because Isograph enables such good local reasoning, and because the interface between two components is as simple as selecting another field, and there's just no boilerplate anywhere to be found, well, because LLMs, they're basically goldfish, Isograph is a really good candidate for, what? Did somebody leave this really old-timey phone here? Hello, I'm presenting. Oh, what's that? The time-traveling host of Impossible Feats Skynet Edition? Oh dear, it's 2024 and people are already using LLMs to build janky, unreliable, data-driven UIs, and we don't have 3 years to get it right? And if we don't, humanity will go extinct? Oh my goodness. I wouldn't want to do this. I'm not prepared for this at all, but if somebody travels time and tells you to do something, you got to do it. So let's go ahead and build an Isograph app using Cursor. All right, so this is a Cursor app right here I happen to have available. All it does is fetch my name from the GitHub API. So if we take a look at it, just does this. Let's tell Cursor a few facts, a few things. Let's change homepage as follows. It should have a subcomponent repository list that selects the last 10 repositories. It should render a subcomponent repository detail. It should render a subcomponent repository stats, which should be selected loadably, load the JavaScript for that loadably, make all changes in the same file, ensure that all fields exist, and follow instructions in Material UI. Basically, I'm not cheating. Yeah, so let's see. Paste it in here and tell it what to do. So the gist about this is that LLMs kind of suck at this, so this is only going to work if it's actually pretty simple to do what I ask. Okay, let's go ahead and do this. Let's wait till it's done. Looks done. Let's apply it, accept it, and save. If that red squiggly goes away, it means that we haven't hallucinated any fields. That's a good start. Okay, so let's go back to this. Here, we refresh this. It doesn't like hot module reloading, like I've said. And let's go ahead and add some throttling. This is what killed me last time. We'll see some loading states. So we'll see one here. And then we'll see these loading stats here. And you'll see a whole bunch of follow-up requests for that repository stats component. OK, so now let's take that. Let's get rid of this slight delay. Now we'll go back to Cursor, and we'll tell it to re-expose the add star and remove star mutations. So this is basically adding a field to the repository object called add star, and that will basically be a function that when called executes the add star mutation. And in addition to that, Isograph will remap the ID from the repository to the input.starable ID mutation. And it will automatically refetch exactly the correct fields that are selected in that case. Okay, cool. It did a good job of this. Oh, even though I wasn't even on schema extension. That actually usually kind of messes it up if I'm on the wrong file. Okay, so let's do that. Save it. There's no visible changes to this. So as long as, yep, it accepted it. So the last thing we'll do is let's change homepage as follows. Add buttons to repository stats that call add star and remove star, re-expose fields. Okay, let's paste it here. Oh, I'm in the wrong file, so that's probably going to just hallucinate an entire file. Okay. Doing this. Kind of wait for a little while. Okay, it did it. All right. Cool. looks like it roughly did the right thing, so hopefully it doesn't mess anything up later on. And yeah, you're done. Let's apply and accept. And now, if this add star red squiggly goes away, it means that, okay, cool, we didn't hallucinate, everything worked. So now if we go here and refresh, what you'll see is that when I click the remove star button, it automatically refetches the star count and whether I refetch that. But if we go back to the code, well, we didn't actually need to explicitly state that. That is all happening deterministically by by Isograph, the framework. And that means, from the perspective of the LLM, this is really, really easy. It just has to do the absolute bare minimum, and the right thing just happens. Okay, well, that's my point. Isograph is probably going to be pretty good for LLM-driven development. Let's continue. Oh, sorry. Yeah. All right. As of this morning, I got a heck of an announcement for you. As of this morning, Isograph 0.20 is officially released. This is chock full of amazing features. Client component fields, loadable fields, automatic typing, compiler watch mode, network error handling, mutation field, more control over how we expose mutation fields, garbage collection, fine-grained re-rendering, and so much more. But it's not going to get to 1.0 on its own. I need you. Yes, you. I need you to kick the tires, to find and report bugs, to help drive prioritization, and just to give it a try. But if you want to make fundamental contributions to a fast-moving and I think groundbreaking project, then come help out as a developer. I can provide you with whatever support you need or however much freedom you want, whatever works best for you. But sort of more importantly, if you think that web apps should be performant out of the box, if you think that writing boilerplate isn't the highest and best use of your time, if you hate managing invariants, then come give Isograph a try. And just as a side note, this presentation contains an Isograph app. That star count in the upper right corner, it's live, so I want to see a number go up as I take some questions. Also, retweet the announcement. All right. Jordan.
Is there a path for the loadable to use defer? Is that like a thing on the roadmap, or is that?
Yes. Yeah, it's on the roadmap. It's very far out. There's like several intermediate steps. One is like currently we are fetching during render. The first intermediate step is to fetch when the network response is initially received, not during render. And then the later one is probably to sort of incorporate proper defer. And then there's also like a few extra versions of defer that are like not super well supported right now, such as like only asynchronously loading the JavaScript, but not the data and stuff like that. There's just like a few more versions that need to be handled. So, back there.
Would the kind of compiler like pull everything out into static content that could be like a trusted document or something like that?
Yes, I don't support persisted operations or trusted documents yet. But yeah, 100%, it's absolutely something that can happen. You can probably do it on your own right now because the query text is just in generated files. And if you want to do that at build time, you can. But I haven't really felt the need to do that quite yet. But yes, certainly. One last thing. Oh, yeah, go for it.
Can you talk to that time traveler and ask them, in how many years Isograph will be production usable?
Almost in time for this presentation, actually. Hopefully pretty soon there is going to be one actual production user of Isograph, which is a real company that makes real money and will be using Isograph. Fingers crossed, we'll be able to announce that pretty soon. And the last thing, I guess this just like kind of fell off, but I don't know if you know, oh, it's because my computer locked. If you all noticed, there's a sneak preview of syntax highlighting, unreleased, but we have syntax highlighting, a VS Code extension, go to definition, all that stuff, it's going to happen as well pretty soon. It didn't quite make the cut for version 0.20. Yeah?
Is that based on language server?
Yes, yeah, it's a language server protocol.
So
Yes, I think so. I think it should be pretty easy to incorporate into other things, into Replit and NeoVim, et cetera. I don't know exactly what to do with that, so like I just have like the VS Code wrapper right now, but like I think it should be fairly easy to do that. So far, it doesn't do anything non-standard. So, yeah.
So everything you've shown here is React. I saw that there was like a import from Isograph/React. How extensible is this to other web frameworks, and maybe more spicily, like could this be used for mobile clients as well with some modification, lots of modification?
Yes, 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 and a third yes. So yes, in terms of other frameworks, there's sort of a core, which is like there is a normalized store and it adds like, like has subscriptions and stuff like that, which is all pretty framework agnostic. Then there's like a very thin wrapper around React and the React API. So that should be fairly simple to, I mean, it'll take time, it'll take work, but like it should be easy to have like some sort of Svelte or Angular integration. And I certainly want to do that. The second thing is other languages. The generated files, they contain the query text. They contain some basically JSON objects that like describe what we're doing in various circumstances. And they contain an import of the function that you specifically exported. So like, a link to this thing. All of what I said is doable in other languages. So I think it should be fairly doable to make Isograph work in Objective-C and Kotlin and so on and so forth. I definitely want to do that, especially because one of the things that I want Isograph to be able to do is to allow you to write these client fields here, and then if necessary, move that execution up to the server. So essentially something like React Server Components. And in that case, it makes a lot of sense to think about this from like a multi-client perspective, because it doesn't matter if you write your full name resolver in JavaScript or Objective-C. If you're just getting the concatenated string, then it can be used across multiple clients. And the last thing is that GraphQL here, it's also an implementation detail. In an ideal world, we would be generating some sort of query that's sent to the back end or some sort of trusted document, but it doesn't have to necessarily be GraphQL. It could be GraphQL that goes through something and generates SQL, or it could be SQL directly or some other RPC-like framework. Yeah, so I think that there's nothing that's inherently tied to React and JavaScript right now, other than the implementation. So. Awesome. Well, thank you all so much for coming. I really appreciate it.